All right, in this section, we are going to be looking at percent application. So we're going to be looking at what percentages are, how to find percentages, and how to use percentages in application problems. So the word percent or percentage is the expression of a number as part of 100. So the word percent literally means per 100. So it's a way to express a number as part of 100. So to express a fraction as a percent, we're first going to divide the numerator by the denominator. So just as a quick reminder, the numerator is the top number in a fraction, and the denominator is the bottom number in the fraction. Then we're going to multiply the quotient by 100. So the quotient is the result of that division. This can also be done by moving the decimal point 2 places to the right. So when we multiply by 100, that's the same as moving the decimal place 2 places to the right. And then we add the percent sign at the end of the number. If we want to express a decimal as a percent, then we're going to move the decimal point 2 places to the right, which is the same as multiplying by 100, and add the percent sign. So in our first example here, we have some fractions and some decimals that we're going to express as percentages. So the first one here is 1/8. So we want to express that as a percentage. So the first thing I'm going to do is I'm going to type into my calculator 1 divided by 8. And that gives me 0.125. Now I'm going to move the decimal place 2 places to the right. So I'm going to take this and I'm going to move it 1, 2. And that turns this into 12.5%. So if you've eaten 1/8 of a pizza, then you ate 12.5% of that pizza. Second example, 38 out of 42. So type that into the calculator, 38 divided by 42. Now this one gives us a much longer string of decimals, so we want to make sure that we always give at least 3 places after the decimal point when we write down the decimal. So this gives us 0.90476 ... There's a lot of numbers after that. So when I write this down, I want to go to at least 1, 2, 3 numbers after. So 0.904, but I'm going to look at the 7 to determine whether the 4 stays a 4 or gets rounded up to a 5. And it's going to get rounded up to a 5. So 38 over 42 as a decimal is 0.905. And then I'm going to move the decimal point 2 places so that this becomes 90.5%. So if you took a quiz and there were 42 questions on the quiz and you got 38 of them correct, then you would have scored a 90.5% on that quiz. And then the last two are more straightforward. So C, we're just going to move the decimal point 1, 2 places. So 0.023 becomes 2.3%. And 0.67, move the decimal point 2 places. That becomes 67%. So taking decimals and fractions and turning them into percentages. So then we also want to be able to turn a percentage back into a decimal. We're not going to go back into fractions. We're just going to go back to decimals. So the first thing we're going to do is remove the percent sign, then divide the number by 100. This is done by moving the decimal 2 places to the left. So you can move that decimal point 2 places to the left, or you can physically type the number into your calculator and divide that by 100. So I've got 3 examples here where we're going to turn the percentage into a decimal. So the first one we have is 48%. So I'm going to remove the percent sign. So this becomes 48. And then the decimal point is after the 8. So this is like the number 48.0. So then I'm going to move that decimal point 2 places to the left. So going backwards, the opposite direction than we did initially. So 0.48. Then the second one, 3.5%. Again, I'm going to remove the percent sign. So that leaves us with 3.5. I'm going to move the decimal point 2 places to the left. I have this empty space here. When I go to write the number, I'm going to fill that empty space with a 0. So 0.035. And the last one, 250%. I'm going to get rid of the percent sign first. 250, and again, the decimal point is after the number. So this is like the number 250.0. So I go ahead and I move that decimal point 2 places to the left. And this is 2.5. So going backwards then, turning the percentage back into the decimal. So those are the basics with percentages and decimals that we need in order to use them in these application problems that we're going to see. So then we have percent formulas, and there are 3 components to each of these formulas. We have an amount, we have a base, which can also be thought of as like a total, and then we have a percent, and this percent will always be given as a decimal when we're working with these formulas. So A, P, and B are going to be the 3 forms or the 3 variables in these formulas. So if we want to find a percent, so we're looking for P, we're going to take the amount and we're going to divide that by the base or the total. So think of it like a quiz. Look at the amount that you got correct and divide that by the total that you could have gotten correct, and that gives you the percent as a decimal that you earned on that quiz. And then you take that decimal and you turn it into a percentage like we were doing before. If you want to find the amount, so we're looking for A. You're going to take the base, the total, and you're going to multiply that by the percent. So I know the percent that I got on the quiz, and I know how many questions there were on the quiz. How many does that mean that I got correct? And then finally, we want to find the total or the base. You're going to take the amount and you're going to divide that by the percentage. So I know how many questions I got correct on the quiz. I know what percentage I got on the quiz, but I can't remember how many questions there were on the quiz. So 3 different percent formulas that we're going to use for different types of word problems. Everyone's favorite thing. So we're going to use these 3 formulas for some different examples down below. So the first one, what is 3% of 200? So we've got a couple of things here. So we're being asked to find 3% of 200. So the first thing is I have a percent here. I'm going to rewrite that as a decimal. And now I need to figure out, am I looking for A? Am I looking for P? Or am I looking for B? So the easy one to identify is P because that's always going to be the percentage. So what is 3% of 200? Of 200 tells me that that's the total. That's the larger amount. So that's my base. So I'm looking for A, the amount. So the formula to find the amount is the base times the percent. So 200 times 0.03 tells me that A is equal to 6. 6 is 3% of 200. So the next one, 80 is 40% of what? I'm sorry, 8 is 40% of what? So again, I have the number 8 and I have the number 40%. So I need to identify what is it that I have and what is it that I'm looking for. I'm going to rewrite 40% as a decimal, and that's going to be P. That's the easy one to identify. So 8 is 40% of what larger number? 8 is the amount of what larger number? So 8 is A, and we're looking for B. So that formula is A divided by B, no, P. B equals A divided by P. So we're going to take 8 divided by 0.4, and we get 20. So 8 is 40% of 20. Twenty-four percent of what number is 40.8? So again, 24% of what number is 40.8? So 24%, I can write that guy as a decimal, and that's going to be P because that was the percentage. So 24% of what total is the amount 40.8? So 40.8 is A. 40.8 is 24% of what number? I can rewrite that sentence to look like the previous one. So we're looking for B again. So 40.8 over 0.24. So 40.8 divided by 0.24 is 170. And then our last one, what percent of 90 is 18? So now this one, we're being asked to find the percent. So of 90 is 18. 18 is the amount, and 90 is the total. So the formula for percent is A over B. So 18 over 90 is 0.2. And then I'm going to turn that into a percentage because it asked what percent. So some examples of how to use these formulas up here in some various word problems. So expanding on that, we can also look at sales tax and discounts. So sales tax is calculated by taking the purchase price and multiplying that by the sales tax, and sales tax is always given as a percent that we want to use as a decimal. So we're going to put this as a decimal. And then discount amounts are very similar. Discount amounts are the purchase price times the discount rate. And that discount rate will be given as a percentage, so we want to multiply that by the decimal. The difference between sales tax and a discount amount is that sales tax is added to the subtotal. So the subtotal is the total before tax, whereas a discount is subtracted from the purchase price. And I have examples, I believe I have examples of both of these. So right here we have, suppose that the local sales tax rate is 6% and you purchase a computer for $1,260. How much tax is paid? So we're just going to find out how much additional are you going to have to pay at the register in sales tax. So you know that the computer is going to cost $1,260, but how much additional are you going to have to pay in tax? So the computer has a purchase price of $1,260. And then this is the tax rate. And we want to write our percentages as decimals because we can't do math with percentages. We can do math with decimals, but we can't do math with percentages. So then to find the tax that we pay, we're going to take our purchase price of $1,260 and we're going to multiply that by the tax rate as a decimal. and we get a tax amount of $75.60. So the computer itself is $12.60, but then the tax that we have to pay is an additional $75.60. So what is the total cost of the computer? So our total cost becomes the $12.60 that we're purchasing the computer for, plus the $75.60 that we have to pay in tax. So we end up paying a grand total of $1,335.60 for this computer. That's how much you're going to charge to your credit card, or that's how much you're going to have in cash to walk out of that store with the computer. $12.60 will not get you the computer. By comparison now, we go to a different store that has a computer with an original price of $14.60, but it's on sale for 15% off. So what is the discount amount? And then what is the sale price of the computer? So the price of the computer is $14.60. That's the purchase price. But then there's a discount rate of 15%. I'm going to write that as a decimal, so 15% becomes 0.15. So we find the discount amount the same way we found the tax rate. We're going to take the purchase price of $14.60 and we're going to multiply that by the discount rate. So $14.60 times 0.15 is $219. But now the sale price of the computer is where the difference comes in. Here we're going to take the purchase price and we're going to subtract this discount amount. So $14.60 minus $219 . And now this computer, instead of being $14.60, is discounted down to $12.41. But then you would still have tax on top of that. So sales tax gets added onto the purchase price, a discount gets subtracted from it, but then you do still have to think about sales tax after the discount. So another thing we can do with percentages is we can find the percent that something increased or decreased. So to do this, we first find the fraction for the percent of the increase or the decrease. And we find that by finding how much the item or how much the value increased and divide that by the original amount, or look at how the amount of the decrease. So how much did the value decrease and divide that by the original amount, not the new amount. And that's really important. We're dividing by the original amount. And then once we've done that division, we turn that result into a percentage. So I think I have two different examples here, and then that finishes up this section. So a jacket regularly sells for $135. The sale price of the jacket is $60.75. Find the percent decrease of the sale price from the regular price. So this jacket has gone on sale because it's summertime and they aren't selling as many. So how much of a sale percent did they put the jacket on sale when they dropped the price from $135 to $60.75? So there are two pieces to this. You have the regular price of $135, and then you have the sale price of $60.75. So for both of these numbers, I want to identify which of these numbers is the original price and which of these is the new price, because I need to know which of these am I going to divide by. So because the jacket was originally $135, that's what it normally sells for, that's the original price. And then the sale price is the new price. So to find the amount of the decrease for the first part of this, I'm going to take the original price and I'm going to subtract the new price. I'm going to do this in a different color. So originally the jacket was $135. Now it's selling for $60.75. So that is a decrease of, whoopsies, $74.25. So that's how much they decreased the price of the jacket. So then to find the percent of the decrease, we're going to take the amount of the decrease and we divide that by the original price of the jacket. So the jacket was decreased in price by $74.25, but it originally was $135. So that gives us 0.55. We can move the decimal point and turn that into a 55% decrease. So they decreased this jacket in price by 55% when they put it on sale. So not quite on clearance yet. So there's one example of how to do this. And the key is identifying which of these prices was the original and which one was the new. Because if you flip those and you get them backwards, then your division at the end is going to be wrong. So last part of this section, last example. After dinner out with your family, the bill comes to $45.21. You notice that your father leaves a total of $53. What percent tip did your father leave? Is your father a good tipper or is he stingy? Let's find out. So we can use this same principle to figure out what percent tip did your father leave. So we have a bill of $45.21 and then the amount that your father left, which was $53. So we need to know which of these was the original price of the meal and which was the new one. The original price is going to be whatever your bill comes to before you leave the tip. So that's going to be $45.21. The new price is going to be whatever you leave or whatever your total comes to after you've left the tip. So the original is going to be your pre-tip or your subtotal. Your new price is going to be after your tip, or if you're trying to figure out sales tax, it would be the price after tax. So new is always going to be after the tip or after the tax is added. The original is going to be before you leave the tip, before you add the tax, just depending on what type of scenario you're looking at. So we want to know, what was the amount of increase? How much did we increase the bill by? So now I'm going to take the new and I'm going to subtract the original. I'm trying to keep myself in the world of positive numbers here. So I saw $53 was left. We started at $45.21. So that's a difference of, hang on, $7.79. So a $7.79 tip was left. So what was the, percent increase, not amount, percent. Oop. The percent increase is going to be the amount of the increase divided by the original, because when you're determining how much tip to leave, you determine that based off of your total before you leave the tip. You can't determine the tip after you've left the tip. That doesn't make sense. That makes my brain hurt. So you have to look at the original price, the price before you leave the tip, to determine how much tip to leave. So we have to divide by that original price. So $7.79 divided by $45.21. Oops. 0.172. After the 2 is a 3, so the 2 stays a 2. It doesn't get turned into a 3. We want to do at least 3 numbers after the decimal point when we're turning things into percentages. So this is 17.2%. And then just as a note here, this number is rounded to the nearest tenth of a percent. So it's been turned into a percent, and it's got one number after the decimal point. And that number after the decimal point is in the 10th place. That's why we're going to go to 3, so that then when we turn it into a percentage, it's rounded to the nearest tenth of a percent. So based on this, your father left a 17.2% tip. So not quite 20%, maybe tell him, hey, maybe you should leave a couple more dollars. Maybe leave a couple more than a couple more dollars. So there we go. So those are some applications with percentage problems, and that's it for this section.